have to authorize all people who is like this, who is participating without being using the Unifi account. There is someone wanting to participate with an account, but I don't find it now. Okay, so let's start this lesson. So in this cycle, I shall illustrate the working of a platform called NetLogo that I shall use to introduce the idea of agent-based modeling. So I suggest to all of you to download the NetLogo version for your computer. NetLogo can be used also with the web interface, but it is quite slower and missing something. We shall investigate this the following. NetLogo is not the perfect platform. It is useful for, say, teaching and developing ideas, but it is quite slow, for instance. So you can use other approaches. Maybe in the last lesson I shall present you other kind of approaches. For instance, there is one based on Julia, which should be quite fast. But okay, let's just go on. The idea of agent-based modeling is not new at all. Actually, it is dates back to von Neumann, and the idea is that if you have something, a piece of word, you can imagine to say, for instance, molecules that travel and bounces and interact among them, or animals, or any kind of things. Clearly, you can model this in several ways, but the idea of agent-based modeling is that of seeing each element as a kind of, say, robot, and so try to program the interface as if it were composed by several interacting agents. They can interact among them, or they may interact with the environment, and then the environment can interact with the agent, and so on. For instance, there could be a kind of field, or this could be animals, and the field is the grass, and they can eat grass or something like this. And so this is the approach. And clearly, you can use this paradigm using any programming interface, but some of this platform are specifically done for working on this. So let us examine how NetLogo works, so that you may be more so you can become more familiar with this kind of approach. Let me launch NetLogo. So when you download and launch NetLogo, you are for registering the presence, you should use the form that I provided you, and that I can again show. So let me let other people. Someone is trying to enter and then disappears. So the form is this one. So you should go to the page. Don't write your name and number and if number here. Use this form and register today as the lesson of 25th March and so on. Okay, so Angela and all the others that had written, I can copy this and put into the chat. So register here so that I can easily extract your presence to today. Okay, so let me back to NetLogo. So the idea is this one. These black things here is the world. The world is composed by patches, small pieces of ground, in some sense. Oops. And so this is, for instance, the patch with coordinate 0, 3, and I can send a message to this patch. For instance, ask patch 0, 3, set your color, then I shall illustrate all these elements, to white. Okay, so you see that now this patch has changed his color, and here it is the view centered on this patch, and so you can see the enlarged view of this patch. Okay, so the world is composed by a grid of elements. Each of them cannot move because they are fixed in space, but it can, say, have variables, respond to messages, and interact with other patches or with other things that are on top of this. Okay, so in order to design your interface, one of the advantages of NetLogo is that you have all together when you download or you use one application. So you have both the interface, the possibility of changing the interface. For instance, you can add a button with say some command. Typically, there is a button that is called the setup that arranges things here. And you also have the code here. For the moment, clearly it is completely empty. And also an info tab where you can describe what your program does and so on. So essentially it is all self-contained, and so you can download or retrieve some of these programs, and if you don't like it, you want to extend, you are free to change it. And okay, so you have to learn a language which is in some sense quite different from the usual ones. It is inspired by an old language that was developed at the beginning of, say, artificial intelligence essentially, I think in the 60s, which is called the Lisp, but we shall come back to this after. Okay, so the elements that can live inside this world, I say that they are patches. You can have turtles, create turtles. I made this 3 turtles. Sorry, this, and then I can also send a message, but I can just create a turtle. The default shape of the turtle is an arrow, but you can change clearly the shape. You can change the shape directly here in the menu that comes out when you click with the second button of your mouse or holding for instance, in my Mac, I have to hold the control key in the keyboard. And then, for instance, I can say, okay, I don't want this, I want it to appear as a car. Let me, a car. I wrote it in the wrong way. Car. Okay. Then I can change the coordinates. For instance, I can move it to position 5. So you see that now this is in the center. This is the coordinate 0, 3. This is now coordinated 0, 5. And the others turtle are still in the middle of the word. Clearly, you normally don't use this interface to change things. You use the code and the buttons in order to have something. So let's start with a very simple exercise. I want to, I don't know, populate this interface using just for the moment just the patches with two colors, say green and red, and I want to be able to establish the percentage of green with respect to red. So this is for introducing another another element, which is a slider, and this is, I don't know, green density, and then minimum 0, maximum, maybe we can use in percent, for instance, and maybe I can put it before. So I fix the percentage of green that I want to have in this world, and then I press setup. And so now I would like to, yes, speak, Leonardo. You wanted to say something, Leonardo? Okay. You raised your hand, maybe Leonardo Squilloni, you raised your hand, but maybe you didn't want to do that. Okay. So let's see how we can program this. Remember that it is an agent-based approach, so you don't iterate on all the cell as you would do in a standard programming language. Rather, you send a message to an ensemble of agents asking for something. So you can the ensemble of all patches is called the patches, clearly. Remember, you have to always to think in terms of sets and lists, because the language is done in this way. So patches is the set of all patches. Clearly, you have to embody this in the command that is called, maybe, for instance, using setup. So I say to setup, which is the interface for declaring essentially a subroutine. Normally, you clear all in order to wipe out everything. Giovanni, use the form to register yourself to the lesson of today. And after you can ask patches, then the idea is that each patch now executes this piece of program, which is here. Okay, so the idea is that I ask to all patches to do something, and in order to, you can generate a random number, and if this random number, so if random float, random or random, we can use just a random integer, 100 less than green density, set color green. Maybe I can ask all patches first to set the color red, and if with a certain probability set the color green. This is the idea. We can check for correctness. For instance, here I wrote the wrong keyword. Okay, so at least formally this works. And now, if I press setup, clearly all of these patches execute this command, and clearly changing this slide, I can change the percentage of green with respect to red. So we can already notice something. First of all, that you use these square parentheses in order to group piece of code. The other important thing is that in NetLogo, all the name of variables can be almost can contain almost all kind of characters. For instance, question marks, dashes, and so on. This means that if you want to make to have the minus for a subtraction, you should put a space around your operator, because otherwise it is considered as part of the name of the variable. This is a bit inconvenient for writing a mathematical expression, but clearly it gives you more possibility of describing variables in a creative way. Okay, so then I shall explain why the color of patches is called the P color and so on. But this is more or less the idea. Okay, so now let us say, suppose that now we want maybe to model a fire in a forest. So let's assume that this is now, instead of green density, maybe it could be the tree density. Okay, so tree density, and maybe the color of the ground is brown, so that now I can have, these are the trees, and the rest is of the ground is brown. Then I can, maybe using the mouse, start a fire and see how far it propagates according to the density of the trees. So once that I set up the trees, I need another button that say start fire. So when I click this start fire, I may have the possibility of choosing one of these. I have to program this, and then start the fire. The command interface is done in such a way that a button can be pressed automatically forever, and this generally is used in order that when I start the fire, then it is called together, so that I can either start really a fire or cancel this command and do something other. So the idea is that it's better to use this as if I were continuously pressing, instead of just blocking everything while waiting for some action. But okay, so to start fire, I have to do two things. First of all, I have to check if I pressed the mouse button. So if mouse down, so notice that this is a function that gives true if the button of the mouse is down and false otherwise. But notice that it is composed by letters, this dash, this minus sign, and also the question mark. Normally, the question mark is used for Boolean variables, variables that can be either true or false, but it is completely arbitrary. So if mouse down, ask patch, one given patch, the patch which is mouse X core, mouse Y core. So mouse Y core. So essentially, mouse X core and mouse Y core are the coordinates of the mouse when I am inside the world. So it could be used for several purposes. Normally, you only use them when you press the button of the mouse, but you could use otherwise. These are real numbers that can take all values. I shall show you then which kind of values can be. But when you pass it to a patch, they are rounded so that they become integer numbers, which are the coordinates of the patch. So, and set p color red. Say this is a signal that it is fired. For the moment, just stop here, just to check if everything works. I have to close the parentheses. Okay, so when I start fire, if I click somewhere, clearly it can be any patch, we can start a fire there. Maybe we could make this only if I click on a tree. So if p color equal green, then p color becomes red. So that, for instance, if I have an empty background, I cannot start a fire. Now only if I have, say, certain background, I can start a fire in some place. Oh, please, if you have questions, comments, something is not clear, please talk, because I'm sure that if I am not clear in some point for one of you, I am not clear for all of you or many of you. Okay, so this is the idea. And then we may say, we may set up a procedure so that it continues to spread the fire until there is a possibility. So let us, for the moment, do this procedure by itself, and then we can say either use another button or call it from this. So to fire, for instance, now we can do several things. We can either assume that when a tree is in fire, it stays in this state forever. Maybe it could be not a fire, but maybe some illness, something like this. Or it can come back, or maybe become brown or black after some number of steps. For the moment, let's assume that it stays red forever. So to fire can be either a procedure for getting this new. Okay. Okay, we can choose either to have a procedure for the red patches to propagate the fire to neighboring green ones, or it can be a procedure for green cells if they have a neighboring cell which is red, it becomes red. Let's try both procedure. So this is a fire red, say. So this is a comment, a procedure for burning trees. To fire red, essentially ask neighbors for. So remember, no, neighbors for. Remember that we have to use sets. So patches we have already seen is the sets of all patches. Then there are other pre-built sets. One of these is neighbors for, which is for each patch the set of the 4 neighboring one. And clearly there are others that I shall show you in the following. Okay, so I send a message. So each patch which is red, then I have to select the patch which are red, may try to propagate the fire to neighboring one. So if the color equal green, because this, remember, this is a message which is sent to a patch nearby a burning one. And so if it is there is a tree, set p color red. So this is essentially the procedure. And then I have to send this procedure to all red patches. So I may use, for instance, another procedure to fire ask patches, but not all patches, patches with p color equal red. So essentially fire red and closed end. So now this is the typical operation in NetLogo. You take a set, this is the set of all patches, with the operator with, you filter this set according to some property. So now this is the set of all patches which have color equal to red. And then I send to them I invite them to follow this procedure. So we can, first of all, check. We can test fire, just sending it, and you see that indeed it does something like this. And then I can now call it if mouse down, and then I may, I don't know, put here fire, so that now I set up, start the fire. Okay, maybe it is too fast. I can slow down things. Start the fire. Okay, you see that indeed it does something something which is not working very well, because instead of just okay, because clearly put here it works until as far as I keep the mouse down. So if I keep the mouse down, the fire propagates, okay, which could be what I want or not. Otherwise, if I click and then release, it stops. If I re-click it, then it continues again. So maybe this is not what I want, so maybe remove this from here and put another button, say fire, forever. So we can say start the fire here, here, and I don't know, here. And then I can fire and see the propagation of fire without having to keep the mouse down, the button of the mouse down. Okay. So this is a possibility. I can also use another approach to fire green. So this is a procedure for non-burning trees. So to fire green, I can say if, because I assume that this is a message sent to green trees, so to patches, which are trees, and so I have to ask if there is any burning tree neighboring to you, then you become a burning trees. So neighbors for is the set of 4 neighbors with p color equal red is the set of neighbors that have color equal to red. The operator any takes a set and returns true if this set is not empty, if there is any member in this set, or false if this set is empty. So it is an operator that ends with a question mark because we assume the convention is that operators or variables that return a Boolean are denoted by a question mark. So if any neighbors with p color equal to red, set p color red. Okay, and so I can test instead of fire red here, I can put fire green. And so set up, initiate the fire here and here, and then fire and not working. And let's see. Okay. No, I have to send this message to the appropriate pages, because now I'm sending this to pages with color equal to red, which is not good. So essentially, let me copy all this. So this is fire, and this is called, say, fire alternative. Now I'm sending this to pages with color equal to green. Okay, and so let me put another button here, fire alternative forever. So okay, so you see that essentially I can now use both fire. Now fire is not working. Ask pages with okay, because I still have this commented. Okay, fire, if I want to send a message to firing to trees which are in fire or burning, or this one if I want to send a message to trees that are not burning, but you see that the effect is the same. This is just to show that there are several approaches that you can use. So maybe I can save this with some name so that I can upload fire test, say, and I can upload this to the folder that I don't remember which is, so that you can have directly on the teaching. This one should be this one here, fire test. And if it is okay, let me check. You should be able to why is it not appearing here? Something wrong. I have to check. I was pretty sure I put the link. Okay, something was the page is the same, but something was not working. So now here you should the fire test. Okay, so if you want, there are already a lot of other models that we can use or not, but in any case, this one that I have just prepared can be retrieved in this from this page. Okay, so you can check and see if what I illustrated is can be used. Okay, questions for this first example? Okay. So the second example will be using, say, turtles instead of patches. And then we can make another example in which turtles interact with patches. So let me start. Yeah. First of all, I shall show you that there is a material in the web. In particular, there is this NetLogo dictionary in which all operators and variables are described. So, for instance, we can check the width here. Okay, so with operator, and so you see that it takes a set of agents, an agent set, then the operator with, and then something which is called the reporter. It means something that returns either a true or a false. And the idea is that for each element of these agents, this reported is evaluated. If it is true, then it is kept, otherwise it is discarded. And finally, you have the agent set filtered using this reporter. So let's see here the usage. So you see here, ask, maybe I can increase the size, ask patches with, so this is the reporter. It is something which is either true if the color is equal to red or false. And so for each element of this, all patches, they this things is evaluated. If it is true, it is kept, otherwise it is discarded. So this is one of the reasons for which NetLogo is slow, because it uses a lot this kind of operators, and you have to scan all elements in order to keep those that you want to use. Another thing to notice that the equal sign is not used to assign a value to a variable. You have to use the keyword set. It is used as its logical meaning. So to compare if something is equal to something else. So I think in Pascal is something like is used in the same way. In some language, it is used in this way. In other, you have to use equal, like in C and other languages. But the thing that it is not so easy to remember is that to assign a value to a variable, you have to use the keyword set and not the equal sign. Okay, so let me come back to this dictionary. Here you see that you have examples. For instance, patch is with p color equal to red. This is equal the same as we used. Count, for instance, is an operator that takes an ensemble, a set, and counts how many members are in this set. Okay, so this is just for showing that when you don't know how to do or what an operator does, you have to use to go to this dictionary. You can also ask, select something and ask for a help directly about these things. Okay, but you can imagine this. Okay, so let me come back to interface and start from scratch. Okay, now, for instance, I can, I may have, say, I may create a turtle in the middle and have it perform a kind of random motion and maybe leave a track of this so that we can visualize the random motion of something. So again, generally I start with the setup. Then normally I can have some slider to arrange for some properties. Maybe then we add. And then typically I have a go procedure that stays forever. So if you click on the code with the second button of the mouse, you can detach the code window so it can be useful so that you can have a code and the interface side by side. Okay, so to set up and so the first thing is always a clear all that can be abbreviated as a CA. And then create turtles. How many? One in the middle. And okay, I for the moment maybe I can say set the shape circle or maybe ant, and set color yellow. Okay, so first of all, you see that ant turtles, differently from patches, can have a shape. You have here in the tools the shape editor. You have some predefined shapes, like for instance ant. No, you don't have ant, you have bug, maybe then I can use a bug instead of ant. You can import from library, you can import from model, for instance, from library, you have, here you have ant, so we can import this. Or you can edit, maybe I shall show in one of the next lessons how to edit a shape. Then another thing is that turtles have colors, so Virgilio or Virgilio, okay. Virginia, you have your microphone on. Okay. Okay, so you see that here we can also increase the viewer. We have a yellow ant in the middle. They use the color while patches use p color. This is done because in order to make simpler to have turtles to interact with the patches, because essentially the idea is that the turtles can directly access and change the properties of the patches they are on. So this is a, okay, let me show. This is turtle 0. Turtles, while patches are identified by their coordinates because they cannot move, turtles have a serial number. So this is turtle number 0. I can inspect as I did with patches, so I can have a view. I can also follow this a given agent. But so if I now ask turtle 0 to set p color, say green, what happens is that p color is a property of patches, not of turtles. But since the turtles can access the properties of the patches below it, what happens is that the patches below it takes the value, takes the color green. For this reason, they use different, say, names for the same property. So color is a property of turtles, while p color is property of patches. So other is the coordinates. X core is the coordinate of a turtle, and p x core is the coordinate of a patch. So this makes life a bit easier. Okay, so set up. Another thing that turtles have is the heading. I mean, let me inspect this again. If I change the heading, set the heading 3, heading, the turtle rotates. So heading is the direction in front, in some sense, of the turtle. The coordinate system in NetLogo is a bit different from the usual one. 0 is north, not east, and positive degrees are in clockwise fashion. So it's exactly the opposite to what is usually done. So if I set heading 45 degrees is northeast. If I ask 90 degrees, they work in degrees. 90 degrees, oops. 90 degrees, it faces east. Okay, so now the idea is that we may say ask this ant to go in the direction of its heading for a certain distance, then make a turn of a certain quantity, and go on. So maybe these two things, so the distance and the turning can be triggered using sliders. But let's try first to do this. So to go, okay, ask turtles. I ask all turtles. Clearly, I have only one, but maybe in the following I can have more than one. Ask turtles, forward, say, some one for the moment. Then we can make maybe a random amount. And then it can turn right with the command right, or left with the command left, or I can directly manipulate the heading. So right means that the heading is added 90 degree modulus 360, and left it is subtracted 90 degrees. So clearly I can go right of a negative amount or go left with a negative amount, and I have the opposite behavior. So suppose that I want to turn left or right with an angle, say from minus 90 to plus 90. So right, a random from 0 to random to 150, say 180, minus 90. So essentially, if this is 0, for instance, it goes minus 90, so goes left, turns left. If it is 180, it turns right. Otherwise, it turns something in the middle. Let's see if this works. And so go, maybe too fast. Let me start. Okay, so this is a kind of random motion. Maybe I can ask turtles to put pen down. They have a pen of the same color of their color, so that now I can trace the random walk of this ant. You have seen that in this moment we have a periodic boundary condition, so that when it exits north, it enters back in the south, and so on. All of this can be controlled by selecting or clicking with the control button, with the second button. So you see that now you can change a lot of things about the world. Where is the origin? In the center, or in a corner, or at the middle of the edge, or some custom start. For the moment, we can leave it in the middle. So the dimension of the world in terms of patches. So now it goes from minus 16 to 16. So it is 33 cells in the horizontal direction and 33 in the vertical direction. But you can change the size of the patch. You can reshape the size of the patch also simply shrinking the world, or changing the value here, say 12. And okay, then you can also select the kind of boundary conditions. If I remove a boundary condition, I have to manage what happens when the turtle tries to go. In this case, simply it cannot go past. So because forward is not obeyed when it tries to go outside the world. And okay, so this is a possibility. Then maybe I can create not just one, but say 10 turtles. Let them have a random color, which is the default. And so I can appreciate how a bunch of, say, random walkers spread when they start from a certain location. Okay, for instance, maybe I can start all of them with the same heading, set the heading, say 0, so that I can appreciate how they diffuse when they start with the same direction. And maybe I can also add some slider, for instance, this is a forward distance from 0, say, to 1 with increment of 0.01 or 0.01. And the other could be another slide could be the turning angle. Say from 0 to 90 degrees. And so maybe now instead of going forward 1, I can make a forward distance. And then write, instead of random this, random 2 times turning angle minus turning angle, or maybe it is better to say I can use a floating number from -1 to 1 and then multiply it by turning angle. This is another possibility. For instance, I could say do something like this. I can say random. In this case, I have to use a random float to say -1. So this is a random number from 0 to 2. -1 is from -1 to 1 times a turning angle. So I can check that these two gives the same behavior. So set up, if turning angle is small, it in forward distance, say it is more, but I can leave it 1. You see that now clearly the something is not working for the turning angle. Random 2 times turning angle should work, but maybe I have to specify. Okay, now it works. So you see that now the random walkers spread in a cone instead of just in every direction. Clearly, if I set up turning angle quickly, they become turning angle 90 degrees. They quickly become, say, uncorrelated. Okay, if it's forward distance, you can imagine that if a forward distance is small, they travel by small steps. See that I can change the value of parameters while the simulation is running. This can be useful to tune parameters, to explore behavior, and so on. Okay, so this is the second example, and I can save it as say random walkers. And they should be in the same directory as before. And so we have seen other operator commands that have sense only for turtles. Forward means going at a certain distance in the direction of the heading. Right and left, turning right and left. Pen down is to lower the pen and start tracking. Okay, the shape and the shape editor and so on. Questions about this second example or comments? So notice that I would like you to suggest also possible models. So you can start thinking of things to explore, and then you can suggest. I can try to implement your suggestion. Clearly, start with simple things. Okay, now the third example could be ants that, or maybe instead of ants, they could be some kind of chemical molecule that, say, migrates in a porous medium, performing a random walk. If they met a seed, they stick there. And this gives you these dendrites, which has some fractal patterns. This is called the diffusion limited aggregation. So the idea is the following. I start with a single seed, a patch in the middle. Then I have a certain number of walkers that start from the edges. If these walkers that make a random motion are reach the neighboring cell or the neighboring patch of already say deposited substance, they deposit this substance, or they stick there. Essentially, they can mark the patch and die, disappear, and another one is created. So let's try to model this new. So I may have a slide that says how many walkers I have. Walkers number, say from 0 to 100. Okay. Then I may have a setup button. And then I have a go button forever. Okay. Okay, so let's try to code this idea. So to set up, I set the initial seed, ask patch 00 set p color, I don't know, white. This is my seed. Then I create turtles 100, or maybe no. Let do this in the go button. Go. Okay, so say that if there are less than walkers number turtles, I create the missing one. So if count turtles less than walkers number, I create turtles. How many? This minus this one. Minus, no, walker numbers minus count turtles. And I can pass them a first command. So set the shape, I don't know, circle. Set color, I don't know, red. Then I can position them on some of the boundary. So I extract a random number from 0 to 3. So, and if it is 0, I can put things here. If it is 1 and on the top, it is 2 on the left, and if it is 3 on the bottom, for instance. So if then no, if then yes, someone wants to participate. Okay. If else. So if else clearly takes normally a condition, then something to do if it is true, or something to do if it is false. But it can also take several conditions. It is like it can act like an if or like a switch. So if so, let me extract a random number. I can use a local variable using let. So set sets some permanent variable, while let creates a temporary variables. Let r random 4. So random gives you an integer number from 0 to this, in this case 4 minus 1. So r can be 0, 1, 2, or 3. If else, so let's start. R equal to 0, set, say, 0 say it is on the right. So set x core max x core, max p x core. Set y core let me say random y core. So random y core automatically generates a random coordinates, clearly in the y direction, while x core is on the left, on the right, in maximum coordinate. Okay. So else r equal to 1, this is essentially the same. Let me put, I have to use parentheses in order to group all together. So let me set y core max y core, x core random x core. Then say I may put all together here just to have something more compact. Then r equal to 2, I can have something like this. Set x core mean, and then I have just an else similar to this one, which is r equal to 4. Set y core mean, and then this. Why it is not okay? Okay, if else r equal to 0, set r equal to 1 this, r equal to 2 this, and this one. Let's suppose it works. So we can close these create the turtles, we close the if, and we close the end. Minus count turtles. Okay, it is always better to put the parentheses, not mandatory, but here yes. While here I have to use parentheses, then I shall explain why, but okay. So let me test Go. So something color says, oh, this is a kind of error. I can set the turtle variable color to non-numbered red. Yes, because red is a keyword. Actually it is an integer number. You can see here the colors of NetLogo. They are numbers. You can also define an RGB color, but the simplest of things is just to use numbers. And red is 15. So I could put here 15. But clearly not a string. So let me try again. Go. Okay. So they are not really working because I create a certain. Okay, maybe I have to restart. Did I put? No, I didn't put the clear all. Okay, so setup clears everything and go just once. Okay, I create my workers all around the world. You see clearly if I put less and then I put go, they are 1 2 3 4 5 6 8 9 10. Why 10? And here there is another one, 11. Show count turtles, 9. So something, okay. Okay, this one is this one emerging from the opposite because I have not put the boundary conditions. Okay, 1 2 3 4 5 6 7 8 9. Okay, now they are right. Okay, so this keeps the number of turtles equal to workers number, and then I may ask turtles say set heading random 180. So essentially turn at random. Forward for FD is an abbreviation for forward 1. And if so, if any of neighbors, four, say, with the color equal white, is as before, set p color white and die. So this means I ask all turtles turn the heading at random. So maybe no, here 360. So turn around randomly. Go forward 1. So neighbors 4 is the set of 4 patches nearby the one where the turtle is on. If there are any of them with the p color equal to white, so essentially if it is in one of these 4 neighbors, set p color white. So the turtle sets the color of the patch it is on, and then dies, and then it will be recreated here. So this is the procedure that we have used in the second approach of the first example. I'm not asking the white thing to do something, but to asking to the black one nearby the white one. So let's see if this works. This works. I have with takes a report that takes something in parentheses. Okay, now it works. So maybe we can lower the speed. Go. You see they perform a random walk. If some of these stitch to a patch that is nearby in occupied one, it creates a white patch and dies, so another is recreated. We have still 1, 2, 3, 4, 5, 6, 7, 8, 9 turtles. Okay, now we can accelerate, and you see, okay, how these things grows. Clearly, now we can try with some larger world. Say, I can increase the size. Go. So now I don't see almost the workers, but they are here. They are all here. And clearly I can see how it grows. I can change the number of workers. So this is why I have chosen to control the number of workers in this way, so that I can change the number of workers. I can also reduce it, because first of all, they disappeared, are not created. And then I can see how this kind of a fractal grows during the evolution by random deposition. Clearly, this is an effect that is different from asking this figure to grow, because it can, in this case, it cannot be that the branches join, because either there is a worker attaching to one side or to the other, so it may join, but it is extremely difficult. And also the bay that stays here are not easily filled, and clearly this effect is almost impossible to do with the procedure that only concerns these patches. I have to use the turtles in order to have this, say, kind of shielding of base due to the branches around them. Okay, so this is, I can call it save as diffusion, say, diffusion limited aggregation. Okay. Questions? Okay, if no questions, I can now propose to do the same, but in 3 dimensions. Just to introduce another version of NetLogo, which is a NetLogo 3D, which is similar, but now works in 3D. It means that the world, instead of being a square, is a cube. The interface is now separated, because you can say turn the view of the world in different directions. You can zoom, you can move, etc., etc. And so now the interface, you have to draw it here, but we can try to do the same as before. So we can add the slider, which is called Walker's number, the same. Okay, then setup, and then say a go button forever. Okay, so this is essentially the same. And then we have another code window, which is the code for the 3D, but we can try to copy essentially the same things as here and adapt to the 3D version. So now I can close this, otherwise we don't see clearly. Okay, so the setup, clearly I have now to ask to patch 0, 0, 0 because we are in 3 dimensions, so we have 3 coordinates. So the setup now creates a block in the middle. And this is essentially the same, but now I have more, no? I have 1, 2, 3, 4, 5, and 6, say, walls, sides. So now it is essentially the same, but I have to extract a number from 0 to 5. So if it is 0, say, I may set X core max X core, but then I have to set both the Y and the Z core. And the same for the rest. Z, Z, Z. And clearly this is now R equal 4, and I have to add the condition for, say, R equal 5, so that now Z is the minimum Z core, and I have to put Y and Z random Z core, Z core, Z core, Z core, and finally the default is very similar. Z core now is a max, Z core, and the same, and the rest is the same. If set now, oh, somebody is asking. Now I have not only the heading, but there is also a pitch and a roll. Ora, the roll we don't care because so it is like an airplane, no? So you have the one angle is in this plane, one angle is this one, this is the pitch, and the roll is how things can move in 3 dimensions, but we don't need. So essentially we need just the heading and the pitch. And clearly now I don't have the neighbors. Let me check. Neighbors should be neighbors 4, neighbor 6. NetLogo 3D. Let me check. Okay, now these are neighbor 6 because we have 6 neighbors. And the rest should be the same. Let me check. Okay. I don't use very much the 3D version because unless particular case, it is very difficult to see something in 3D. But you see that now something very similar is happening, so that I have something growing in 3 dimensions. And as before, I can set the world now, I don't know, 40, 40, and 40, and with the patch size smaller. Let me see. Setup, go. And now, yes, somebody now participating. And so you see that now we can say see growing much say in a much larger space. Clearly we have to wait a lot, but we can maybe increase the number of workers. You see that it is in perspective, so the turtles are bigger when they are nearer and smaller when they are farther. And okay, so you see that we can say have also a 3D version of our tool or our program, but unless there is a way of, say, sectioning or moving, I can. It is very difficult to see what is going on in a 3D environment. So I think that for the most of examples, I would work in 2D, but I can also save this in the same directory, save as, say, in the same, I don't remember which one was, the directory, I don't know why it is not showing the full name here, but I don't know. Okay, this one, complex word, my drive, should be this one, NetLogo 2000, and diffusion image aggregation, say 3D. Okay, so you should now have also this example. Are there questions, comments, suggestions? No, everything is clear. Okay, now the last example, I'm coming back to the version. And for the last example, I shall make use, say, of a model in the library. So with the NetLogo, it comes a large library of already prepared programs that you can use, modify, adapt, and so on. And this this model is instructive because it allows us to show another say class of agents. So we have seen patches in the world and turtles. For instance, this is a set of turtles with the shape of a human, so a man. So set up, the code is very simple. To set up a clear all, set the default shape of turtle's person. This is another way of setting the shape. Instead of setting individually for all turtles, I can ask set the default shape. Make turtles is this procedure here. So create the turtles, and I create how many turtles I decide here. So if I set 18, I create 18 turtles, and otherwise I can create a lot of turtles. This, and you can also have some procedure that helps you in say putting turtles in some predefined way. Layout the circle is a way, so you can inspect with the NetLogo help, look in the dictionary, and so layout the circle is this one. You take an agent set, a radius, and or a list of turtles, and you can arrange them on a circle. It is like, say, having the first in degrees 0, the second degree 360 divided by the number of adjancent and so on. Just to see that I can have adjancent or lists of something that are not the same, and maybe I can keep this in a corner so that I can illustrate this difference in a moment. Okay, so then in the setup you have these find all components and color giant component, which is actually not used in the setup, so I can leave it away for a moment. And they're here, but they are used essentially in the Go. I don't know why they are put here. And then reset ticks. It has the scope of resetting the counter of ticks, and you in the Go procedure normally you also have a tick that increases the counter by 1. So the setup is simply for the moment creates a certain number of turtles, arrange them in a circle, and that's all. And okay, this procedure find the components, and so it had just the scope of marking one of them in red. Then you see that go once and essentially they are the same command. The difference is that this button only asks go for one time, while this is a forever button, so continuously call the procedure go until you stop it. And so let's see what Go does. Okay, first of all, let's see what happens. The idea is that you pick two people that are not already connected, and you connect them. This is the idea. And then you mark in red, you call these ensembles of connected people a component, and you mark the component with the largest size, so that has more people connected. And this is, in some sense, what happened at the beginning of internet. Suppose that these are computers, not people. And then the offices started to connect servers or computers. And then at the beginning, you have isolated components, you see. Then at a certain point, say two components may fuse, or you can have somebody adding to a component. You see this. So there are still a lot of components, but one becomes to be larger. And then when you continue to do this, you see that this is the size of the largest component. At a certain point, there is a sudden phenomenon for which almost all people or computers belongs to the giant component. So you see that now we have a transition. Clearly, this line marks the transition for an infinite number of people, but we can try to go faster. You see that essentially this is what happened with the internet. At a certain point, the already existing local network have been connected in a global way, and finally you quickly have a situation in which almost all the world is connected. Clearly, if I increase the number of people, the phenomenon is more evident. So they start to connect, and at the beginning the the largest component grows slowly, but at a certain point you have a quick transition to an almost to a world which is almost connected to in every node. Okay, but for the point of view of NetLogo, it is interesting because we have the opportunity of saying that beyond the patch, beyond the turtle, we can also have a link which can be inspected as patches and turtles. A link is simply a connection that connects two turtles. So the link is characterized by the two turtles that are connected. Here it can have a color, for instance, yellow. It can have a label, say a link. Clearly, you see this only here. This is too large. Even though you can choose not here, no. Maybe in the word here you can choose the size. The size of labels of a font used for labels. Font size, say 5, so that it becomes smaller. And then links as status can be hidden or not, and other. It can have different shapes, and you have also a link shapes editor here. Now you can add, for instance, you can add more lines, and you can have a carved link. Maybe it is too much, and so on. Say 5 or 3. Okay, and okay, there are some things that you can do. And so let's have a look at the code. So the idea is that find all components, color giant component, and then ask links of set the color of end, because I have already colored the giant component. And then there is a procedure that is defined in the following that tries to arrange all these components in order not them to overlap each other. So find all component. You see that now turtles have other variables, not the default one, but for instance, in this case, there is another variable which is explored. The fact that it ends with a question mark suggestion that it is a Boolean, so a logical variable. And then you see that there are also global variables like a component size, a giant component size, and giant start node. And okay, now the idea is that start, you see, start examining all turtles. So you take each turtle, one of turtles, one of is an operator that takes a set and returns just one item of this set. But the set is not the set of all turtles. It's the set of all turtles which have not been explored, so which have this variable explored set to false, because with not it becomes a set to true. And clearly, if start when at the end it returns nobody, so if start is equal to nobody, stop. So it means that the go is unchecked. So you can see if as we start is very small number and you go, clearly it stops at a certain point. And so set component size and then ask to start is one of these, and ask start explore, or we can see what explore is this one. Okay, so explored is to link so to ask neighbors to explore them again. So essentially you add, you see, the all, so essentially I started with a random site. If it is alone, simply it sets explored to true. It set the component size to 1. It colors in some gray. Then, since it has no neighbors, it stops there. If instead it has neighbors, it asks them, so it is a recursive procedure, it asks them to explore. Clearly, one of these neighbors can ask again to the first one to explore, but since it has set this explored flag to true, it if this command returns back to the first one, it is explored equal to true, so it stops this procedure, exit this procedure. And then, okay, and then we, then we have a find the giant component, so here. Somewhere there should be a way of finding the largest component, and then I ask to the first one to explore its component and to mark now in red instead of gray. And giant start node should be here. In the procedure find all components. So essentially, I again use the explore the flag to mark, not to explore more than one times the same turtles. And then you see here is a loop forever. So you take one of these turtles, and then again the same as before. If start is nobody, it means that I already explored all components. Otherwise, set component size to 0, and they start to again explore the tree, increasing the component size. And if the component size is greater than global quantity, which is the giant component size, set the giant component size here to this component size and marks one of these nodes, essentially the last one, as a starting node for the giant component. This is used then to recolor the giant component in red. So this is clearly quite a complex model, but just to show you that, first of all, we have now both so the patches, the turtles, and the links, and that you can say ask a turtle to send a command to all other turtles that are connected by a link. I can establish a link among pairs of turtles, and I can use the procedure that call themselves like this, explore and calls explore, recursive procedure, which are quite used in this kind of approach. And finally, as just to end, I promised to illustrate the difference between an agent set and a list. So let me start. So this is a giant component which is in the model library, so I don't put it into the list of models we developed. But so we can start with a new discard. So suppose that I create certain numbers. I can also make a list. Create turtles. Say turtles. Create turtles 10. Set xy random x core random y core random. So just to scatter them around the world. Now, if I ask show turtles, it says, okay, turtles is a set, but it is an agent set, and an agent set has no order. So essentially, it is difficult to list them. So essentially, it is impossible. So okay, or if I list them, they are listed in a random order. So for each say, okay, let me do it in a button so that it is easy. So okay, set up, and then say agent set, and then I want the button to have the same thing as a list. Okay, so let me use the code here. So to set up, I can do these things. So I can copy here. So where is it? Okay. To set up, clear all, and then create 10 scattered turtles, and to agent set, I for each for each. Okay, so for each is let me show you here. NetLogo for each is a way, one of the way for each is one of the for iterating over a list, and so here I cannot use. To agent set ask, say turtles, something like show, say their coordinates, show world x equal, now I explain, x equal x core, y equal y core. So show essentially prints a string. I have to construct the string using the word operator. Word takes a number of things that can be either strings or variables, concatenates all of them, and returns the string. Okay, so in this case, I can clearly set this. Maybe I can use less than 10, maybe 5. Okay, so if now go to the here, setup, and then agent set, say, you see that the agent set, the message is sent to this agent set, but in a random order. I mean that every time I repeat, I have a different order. So maybe clear. So 1, 3, 4, 0, 2, and 0, 1, 2, 3, 4, and so on. This is a so the agent set has no order. On the contrary, I to list. I cannot use the word list because I reserved. List turtles. Okay. To list turtles, set L, say, I have to, I can sort, for instance, the turtles according to their ID. Now, this is a list, and a list can be accessed in an ordered way. So for each L, X in show or in ask X to do this. Okay, so the idea is that I take the all turtles. This is an agent set. Sort returns a list of these agent set now sorted according to some things. If you don't see, if you don't say how to sort, they are sorted in the using the ID. So 0, 1, 2, 3. Then for each takes a list and applies this, in technical terms, anonymous procedure to this list. And this procedure defines a variable. This variable is assigned all items in a list. And then I ask this item to do the same as before. So if it is works, it is a temporary variable, so let. Okay. So now, if I clear now list turtle, you see that it always starts from 0 because essentially it is a list. So clearly I could say maybe instead of regenerating, I can use a globals list of turtles. I can move this here just to be sure that list of turtles, just in order to have just once the construction of the list of all turtles. And now for each list of turtles, let me see. Okay, so agent set again is in random order, and while setup list of turtles, it is not regenerated every time. It is always the same list of turtles, but it is always accessed in an ordered way. So I can have agent set or list of, in this case, agents, but also of anything. If I ask show list of turtles. You see, this is a list of 4 turtles in an ordered way. So, according to what I want to do, I can use agent set or list, but the operators are different. Another thing that you can notice is that this language appears as a parallel language in which I send, say, messages to all turtles, to all patches. Internally, they are sent to the agents in a random word. So we have to be careful. We can see in the next lesson. We have to be careful if we really want to have something applied in parallel to all cell. I have to use some special trick, otherwise it is not sent really in parallel. Okay, then I can save this example again in your shared drive, not this, my drive, this teaching, NetLogo 2000, and I can call it agent set versus lists. Agent set versus list. Okay. I think that for today it is enough. If you have questions, feel free to ask. Otherwise, I give you a rendezvous to next lesson. And remember that if you have to sign using the form when you attend either in streaming or asynchronously to a lesson, so that I can extract the list of participants. That's all for today, and I think I can stop the recording. If you have questions, please go on. Also suggestions